Hello and good morning, good afternoon, good evening, and welcome to this live webinar between Kaito, Ellie Technologies, and Snowflake. My name is Saku and I'm the CEO of Kaito. Before going to the agenda, some housekeeping practicalities. So, first of all attendees are muted. Secondly, there's the question tab that we hope that you use if you have questions. Most likely, we cannot answer the questions during the presentations, but end of the session we will have the Ask the Expert part, and we will have a sort of a panel where the presenters will answer the questions. If we run out of time, the presenters will still keep answering the questions, and you will receive the recording a couple days after this webinar. So if you need to leave before the end of the session, anyways, you will get the answers. We will also post some polls, and we appreciate if you've been active in answering those. You can find the polls in the polls tab of the Livestorm platform. Just to keep it a bit interactive, so we know there's people attending around the world, so you can use the chat feature in the platform to ask questions or have a discussion or chat, and I would like if you could now say where you are actually attending from. So please use the chat window now to answer that question. So today I have my three colleagues here with me, so let's start according to the agenda. Juha Korpela, the Chief Project Officer from Ellie Technologies, will start by introducing you how to make your analytics business driven. Still today we see loads of enterprises where the actual data modeling is based on the source systems. And that makes the data modeling really complex and produces less value. So after that, Roberto Zagni, the principal consultant from Kaito, will continue and introduce you to DPT within Snowflake or with Snowflake. And basically, Roberto will discuss about data platform automation. So how to basically take the next steps after you have basically built your data model business driven, how to make the business model into logical data warehouse model. Roberto will also demo DPT with Snowflake, and why we are today talking about DPT is the fact that today many companies are thinking about how to enable really like streamlined data warehousing and analytics. And one of the key topics is data warehouse automation. And DPT is one of the answers to that question and challenge. And using DPT, you can basically take away some of the bottlenecks that you have in your data warehousing and analytics today. Then, after Roberto, Sami Rouhe, a sales engineer from Snowflake, will continue and go through at least some of the new features that were introduced 2020 Data Cloud Summit that Snowflake had like 2 months ago. He will also talk about some of the features that really reduce the bottlenecks that you really see today when you build enterprise level data platforms and data warehousing. So before inviting Juha Korpela on stage, I guess we will have our first poll. So basically, please go to the poll tab and answer the question that we have visible there. Basically, questioning that how familiar you are with Snowflake, Ellie Technologies, or DPT. So further said, I will invite Juha Korpela, the Chief Project Officer from Ellie Technologies, and welcome, Juha.
Thank you. Good morning, everyone. My name is Juha Korpela, as told. Thanks, Saku, thanks, Kaito and Snowflake for being here. I will be telling you about how to make this whole data modeling thing business-driven. And by that, I mean very specific things. So let me just dig up my presentation here. But there we go. Right. So first we need to discuss a little bit about data modeling in itself. So by business-driven data modeling, or conceptual modeling, as it is also called, what do I mean by that? The idea here is that we are driving in Ellie is that we should be creating data models based on what the business is, not what the technological solution might be. So I have there a quote from Alex Sharp, a guru in this business, who says that a data model is a description of a business in terms of the things it needs to know about. So first and foremost, we're attempting to understand the business and the information within that business rather than trying to model kind of prematurely a technological solution into which we might end with. Also important is the meaning behind the words that we use in the modeling in order to create understanding between business areas and business and IT about the content of the data. So the point here is that when you're doing data modeling like this, you're ensuring that your data is always going to be based on your real-life business, not technological solutions. You're fostering understanding, you're defining common terminology that might be difficult even within different business areas, not only between business and IT and data people. And you can kind of identify the requirements of the data that goes into your solution or that you have to use for your use case. So when it comes to kind of data-driven thinking and business-driven data thinking in data platform building, our point is that it cannot be a technological exercise purely. So the actual business benefits for which you are actually aiming will only materialize if you are kind of basing the data on the real business needs, and the data as it's utilized can be easily linked to those. So I have here 3 basic rules. First, we need to understand what data is available. Secondly, we need to design any data warehousing solutions according to actual business concepts, not the source systems. And thirdly, while we are serving the data to the data consumers, business users, analysts, report creators, data scientists, whatever, it has to be in a structure and it has to utilize a terminology which is familiar to them, which is something that they can realize and understand from the actual real life. So this is kind of a let's say, extremely high-level target architecture of a business-driven data platform. And our idea at Ellie is that basically no matter what part of the platform or the pipeline you are building, you should always be basing your thinking on the business-driven data models, the idea that you are getting understanding of the business from the business of the data contents. You ensure that the right data is being used. You define that, okay, this is the structure there is. I need to have this data in my data lake. This is the structure there is. This is how I need to model my data warehouse. And this is the business. So now I know what parts of this data content I need to provide for each use case. And today, what we will do with Roberto in a moment, as I will invite him here soon, we will be focusing on that middle arrow there. So figuring out what should be the structure of the data warehouse as we are basing it on real life business things. So as an example of technology stack here, what Ellie does, it captures basically those business needs utilizing the methodology of this business-driven data modeling, this conceptual modeling, and then we pass that on. It could be a kind of a technological integration as we have with some tools. It could be kind of a process integration, which we're basically going to do here, a kind of handover from me to Roberto soon, to tools which can create those technological solutions, those kind of technical structures within engines like Snowflake or any other. And then as the data is being provided through some reporting tools or analytical tools, we can ensure that the data as it is being based on the real business needs is actually actionable and something that people can understand better. So we will be building a data model soonish. It might look something like this. This is just an example model here, but our idea is that we want to make these fast and easy to understand, easy to utilize, easy to do, to get the understanding of like the real structure, the real concepts as you see here. We're not talking about tables. We're not talking about reports. We're not talking about systems. So what we're going to do is use the business concepts for the data vault design. We're going to avoid source system data vaults, and we're going to ensure that by doing this in a sensible way, the data vault model that we're going to be creating here is kind of well documented, understandable business. It's faster to build and easier to utilize. And now at this point, I think I'll ask Roberto to join me here. Good morning.
Hi, hello everybody. I'm Roberto.
And what we'll do now with Roberto is I'll attempt to model Roberto's business idea that he has in his mind that we'll be using as the basis of this exercise here, using Ellie. And let's see how that goes. Oh, let's not use the ready-made model there. This is Ellie here. Can you actually switch? Yes, thank you.
Let me close the pop-ups.
Oh, yes, that's good.
Yes, so
thank you.
welcome.
All right, so this is Ellie. This is my personal Ellie environment. One of the great perks of working at Ellie, getting your own environment in which to play around. And I will be creating an empty model here. There we go. This is now going to be Roberto's business. And we will be modeling the business content of what you will soon then use to create this data vault structure. Now, your business is about portfolios, right?
Yes, so for this demo, we have invented a fictional company that we name Squarebox. So it's a financial institution. And just to simplify the model, because otherwise we would have to talk for hours, we have simplified and said that now we are starting to build a new data platform incrementally. And so the first thing that we want to take in this new data platform is showing the portfolios. So this is the small context that now we will build today, now with the model with you, and later what I will show in the demo.
So the slice of reality that we are modeling here is now about your portfolio business. You're an investment banker now or something like that.
Yeah, so it could be an investment bank. It could be a normal bank that has some financial advisor.
Right.
So the fact that in many industries, you have portfolios that contain positions that are some number of stocks or other financial instruments.
Good. Now let's stop there for a moment and let's start modeling this. So what I'm now doing basically is I'm picking the words from Roberto's examples, the description of the business in real life business terms. So you said portfolios. Okay, I am creating a portfolio entity. Good. And you said
we have stock or security.
Stocks, okay.
Let's say stock because it's simpler for people to remember.
Stock, that's a word. Yes. So you have stocks in there,
and you have position because you can
position.
have more or less, and you can change over time how many you have.
Good. So now we know that you have portfolios, stocks, and positions of those stocks in the portfolio. Good. So these are the real life business terms that we're now going to be using. And what I'm doing now is I'm just clicking and dragging things here. That's the portfolio entity. We have the stock entity there somewhere and the position. And as you see now, these are kind of concepts that I've created. Some of these I've already created beforehand as I'm being very sort of efficient with this. But what I'm now doing is I'm trying to explain with Ellie how these things relate to each other. So first of all, the color coding here. So I have already added portfolio beforehand. Portfolio is a black thing here. It means that we call it a master type of entity. We have the kind of color coding here. So it means that we know what portfolios you have. You have a list of portfolios. That's cool. What is a position then? It's something else. You kind of have separate positions for every day, and it changes when you buy things. So we call that a contract type of entity. It's the pink color. It means that it's valid from a certain point in time to another point in time.
And also it doesn't make sense alone. So you cannot have a position without a portfolio or without a stock.
Precisely. And then you have the stock, which is now yellow because I just created that, and we will be changing the color of that if I know where's this right click. Okay,
sorry.
There, precisely, good. So we will be changing the entity type here as master type entity because we know that there are a bunch of stocks, you know, you could buy.
That you name, something that you can count.
Good.
an entity.
So 3 entities. And now I'll just drag the lines here. So one portfolio can have multiple positions of different stocks, and each stock can actually exist in several different positions across different portfolios that you have, right? So let's try to make this a bit nicer. There we go. Okay, this is good. So now you have data about stocks, portfolios, and positions. And remember, we're still modeling the kind of real world, not a database at this point yet. So what next? How do you know what these stocks are priced at?
Well, I think that the most important thing that people care about their portfolio is the value.
Right.
And so that is function of 2 things. One is the stock price, so the stock quotes. So if you want, we can call it quotes or stock quotes.
Quote. Okay, good.
And of course, the time, because this thing changes. So the date
Right.
or calendar, whatever we want to call it.
So the stock quote is a quote of the price at a certain given date. So what we're going to do is adding entity type of transaction. So now it says that at a certain point in time you had this price there, and that is related to the stock itself. So we have the quotes of the stocks as a transaction type entity there. And you see how the structure starts to build here. Let's actually zoom in a little bit so it's easier to see for everyone. All right. And you have also, I believe, the currencies, right?
Yes, we can, of course, it's important in the real life. In this demo, we can leave it out, but the definitely most important thing is the dates. So
right,
the calendar.
right. So we could add a calendar entity.
Yes.
That's something that this is kind of a stylish thing. That do you like adding calendar entities in conceptual models? I usually don't, but it is important here. So let's add that as a reference.
Yes, that is what it is. So, but it's very important to understand the model, because here actually a lot of the important thing is what happens when time changes.
Right. Okay. And then you have the portfolios, and do you know anything else about the portfolios? So you
of course, a portfolio has an owner.
Right,
usually,
okay.
It can be a company or a person. So we don't really at this moment need to model in deep.
Let's add that in any
but
case.
We can,
it,
yes.
It might not be part of your final model, but we can do that. So okay, you have portfolio
But that's definitely
owners.
the important thing, because you need to know who owns what.
Yes. So the portfolio owners can own different portfolios, and you said they can be persons and companies.
Or companies,
right.
or legal entities if you want to be probably, but let's say company.
All right.
That is
so we will add
a good
those,
enough approximation of a legal entity.
Yes. So let's add those as subtypes of portfolio owner, and soon we will have the model here ready. So we have companies. Yes, I have created that already. So let's drag that on there, and there we are. Okay, now of course I would make this a little bit nicer looking if I had my own laptop and everything, but there we are. In any case, the idea is now that what we have here is a model of Roberto's business. We have identified the business entities. What we would do next, of course, would be to define these so that everyone could understand what we mean by a position. So I would perhaps, double click on the position, and we would end up with a glossary entry to write down the definition of that. Right now, we won't be spending time with that. You don't need to look at me typing things. But the point here is that this model here is actually something that we can use in any case that you have, any project you have. This is a description of your business's content of data. It's not necessarily a description of a certain database, but you will be turning this. This is basically a requirement for your data vault solution that you will be developing soon.
Yes, of course, we will take these and we will make it to become something real that we can actually deploy and run and actually have data come in and then, of course, generate all the reporting.
Precisely. But I think the important thing to note here is that we have done this by discussing only in business terms. We have not gone into data. We have not gone into data vault terminology. We don't care about hubs or satellites or anything yet. We only care about what are the entities about which Roberto's business has data.
And I would say that in the end is what our business user care.
Yes, precisely.
Because as a technologist, I might care about other aspects also, but I know that the people that will use my reporting just care about those level of entities.
So this is the documentation now of the data content that is now currently being used in Roberto's project, but he might have an, I don't know, ERP project coming up next or something in which he could use the exact same model to define the contents of his business processes data. So in this sense, it's kind of an independent model of Roberto's business rather than a specific model for a specific use case. All right. I think that's about the model. We're not going to be adding much more detail into it. I think we had the currencies at some point there, but that's not important right
yes, now. We can have currencies. We could even discuss of what happens to the transaction, what will happen when we buy and sell.
True.
Because
so there's actually let's spend 1 minute talking about that because it's an interesting question. So what we have defined here actually is the position of portfolio in terms of it having certain amount of stocks at certain period of time. But this model is now, from that point of view, the position is kind of a snapshot or a look into the composition of the stock in the portfolio. But what we could have also done, and I'll just give you a brief example here, is that we could have also considered the stock transaction, which would be the event in which you buy or sell stock from the portfolio, which would actually change the model a little bit because the data in this is of the transaction type, and you would have to calculate basically the contents of the portfolio in a given moment from basically the aggregating the transactions, which is not what we are going to be doing now, but it is an alternative way of modeling the very same thing. So this is how we actually see that the requirements also affect the conceptual model, in the sense that now it was only required that we want to know about the position of those stocks in those portfolios. But we could have modeled the reality behind that, which is actually the transactions.
Yes, because in the end, I think that a model is something that needs to help you to understand your business, and then that you can easily explain to the people that are using the result of your technological effort.
Precisely. And this also means that we can expand this business-driven model now to cover other use cases. Later, we can add the currencies, we can add the stock transactions, we can add, all kinds of stuff, keep adding on that, and it's still kind of valid as it has been built from the business perspective, not from a perspective of individual IT project.
Yeah, because if we model something that corresponds to the business reality, so for business, position are real and also transaction are real. So, but in reality, technologically, we could have that we get only position changes and we have to calculate the transaction, or we actually get the real transaction and then we calculate the position, summing them up. So some people in the business might not care. Some other, of course, do care because they make money out of many transactions we do. So, and that's, I think it's important because you can screen what is not essential for some level of business user, and you can have a model that explains them what they need to know.
Precisely. All right. That's it for the modeling part. I will let you do your magic now. So thanks for me, and I will be around for questions later. Roberto, feel free to continue.
So, thank you very much.
You.
So, hi everybody. So I'm Roberto, and like we have seen now, I'm working with Kaito. I'm principal consultant here, and today I will walk you through some initial introduction to what we think it's useful when you want to create a new data platform with automation, and then with a demo that will show how we build this kind of data platform in reality. We have built this IDW solution to facilitate the creation of modern data platform that provide enterprise agile data automation. Here you see listed some important characteristics that our IDW solution provides. The first and most important is agility. If we did not know or read it well enough, Corona has taught us that we need to be nimble, to react quickly. we can react quickly when we know where we are, and we can build iteratively. In this demo, for example, we will start with a small part of the actual business, and we will build on top of it. Of course, it's important that a solution is easy to use, because skilled resources are really rare, are really expensive, and what we have done is to use a solution that allows us to build a platform using 99% SQL. This allows us to onboard a lot of your people that is already familiar with SQL and also the data and the models that your company use. A modular structure also allows you and your people to understand better and quickly and to iterate much faster. Then we have to provide a solution that can scale in all dimensions. Of course, speed of computation is important, but it's not the only one. The size of data that you can handle is practically infinite, because in this data cloud, in this cloud data warehouses, you can store and you can process huge amount of data. They are proven up to petabyte of data. And of course, it's also important that it scale the human factor, the amount of people, the size of team, the number of teams. So these are all very important factors so that you can build your platform without having too many bottlenecks. The platforms and the partners that are used, they are proven to scale, and using the best practice allow you to actually build this data platform in incremental way, reducing risk. Also, the quality of the documentation and of the development process that you get out of this new breed of tools allow you to share and disseminate the information more quickly and more effectively, so that you get more brain power in building your data platform. IDW provides also full auditability of the data ingested and full lineage of the process and of the transformed data. So data is only inserted, so we never update or change what we have inserted, and you apply business rule on top of the data that you have ingested. And we handle also complex relation like bitemporality. So the difference between when something happened and when you actually got to know this. Because sometimes it's important that, especially in auditing, you can reproduce what you knew back at some point in time, even if after that you figure out that that was wrong or you had changes in that. And then with the software as a service platform like dbt Cloud, that is a component of our solution, you can even go one step further and simplify your work and processes. So what was a complex process of building automation, now it becomes just software as a service. So continuous integration is configured with just one login and one checkbox. As simple as that. Working with Git and opening pull request is something that is made extremely easy, and also people that has never done this before can start using it in hours. They don't need long training, they don't get lost, they don't get mad of how Git works. That is something that in the past was pretty common. Deployment is one button effort, but of course you can also schedule it. You can have it run, and the same for ETL running. You can schedule it, you can have it run with the REST API. So you can decide how you manage your data and how you run your production system. And also, extremely important, your data is not made prisoner of the data platform. And especially using Snowflake, you can easily share your data with all the departments you want, all the subsidiaries you have, and even in a very secure way with partners. And you can even start to monetize on data that you really want and share with the rest of the world. and you can even provide or use services that will improve the data that you have. Of course, we could have not done all by ourselves, but luckily we can stand on the shoulder of giants and also future giants. So what are the giants and future giants that allow us to provide you such compelling story? I will start from dbt. That is the tool that we use to develop and orchestrate. It brings all the parts together and allow to extend SQL with the logic you need. So we end up, and we will see during the demo, using 99% SQL plus a little bit of Python scripting. It's a scripting templating called Jinja that allow us, for example, to chain the model so that we know the correct sequence. And this makes it the platform well aware what needs to be run. And then we use libraries, because dbt allow us to use software engineering practice to actually develop on SQL. So we can use Data Vault, that is a library that allows quicker development of Data Vault based data platform. So if you want to use Data Vault, you don't have to start from scratch. You don't have to code everything. You can use libraries. And then, of course, the central part of this architecture is a cloud database. We tend to favor Snowflake because beside being available on all the major cloud platforms, also provide you a lot of other benefits. And later you will have a presentation from Snowflake that will detail some of these most recent advantages. But definitely the easy way of sharing data inside and outside the organization is something that it can be really give a boost to your project, because you save a lot of time in what is normally a complicated part of any project, how to move data. So, and then the last but not least important piece that I want to talk to you about is GitHub. Of course, it's important that we store the code we produce in a safe, secure way. We version it. But I think that the most important use of GitHub is, on one side, to allow the human interaction, to allowing comments, to allowing pull requests, so to collaborate on building the code. And of course, the other part is also the automation, so that when we actually open a pull request, GitHub can automatically trigger our continuous integration that is, remember, configured with just one checkbox, so that we actually run the code that we are checking in, we run the test, and we know that we are not regressing. So how does it look like? So how a data platform that we built with IDW look like? On the left, you can see the data sources that generally we find in all companies. So you have databases, you have cloud data that is coming from the cloud, you have files, you have IoT data, and of course you can have APIs and REST services. All of these we have to bring to our data platform. So they land or on the data lake, or you can use data loaders so that you can load directly into table in the Snowflake or your chosen data platform. And then we start the magic of IDW. In the center, of course, you see Snowflake, because it is at the core, because allow you to store your data in any major cloud, move between them seamlessly, so that you can keep your door open. And we store and we use the practically infinite scalability both of storage and computation. Then in this case, we have put Data Vault 2, because it's a field-tested, agile architectural approach to building enterprise data warehouses that embrace automation using best practice and patterns. And this tried at petascale. Huge companies like Lockheed Martin use Data Vault to integrate thousands of data sources and power thousands of people working on that data. It's not a requirement, it's not a forced choice, and sometimes we deviate. But it provides a good and consistent recipe to build enterprise-grade data platform. So we like it, and we anyway keep the principle even when we don't use Data Vault constructs. And then, of course, you see I've been talking dbt and dbt Cloud. They are the tool. Is this SQL-driven ETL development tool where you describe your transformation by simple SQL, and then it will join the puzzle. The base dbt is open source with a huge community, so you can easily find both libraries and support. And of course, you have dbt Cloud that is a commercial software as a service offering from the dbt creators that allow you to move also the coding experience in the cloud and provide a deploy pipeline, continuous integration as a service. It is optional, but it provides a huge value for the money, and so we suggest to use it. And I even have to tell you that we do it despite the fact that we don't earn anything on it. So it's just that it's good to have the simple as possible project so that your people will concentrate on making what is important, building your logic, not keeping the system running. And I said we have GitHub, but we can have other Git-enabled storage, but we tend to use GitHub because the integration is really one click. So it makes, again, for the team to concentrate on building the logic and not building the platform. And then on the right, you see the end-user solution. I have exemplified that with a report, but it can be machine learning, API, whatever. In the end, whatever can read a SQL database and can connect to your decided platform of choice, it can be a client. And of course, there are best practice to keep this client orderly, to manage the data and govern how they access the data and what data they access. So coming towards the demo, I told you already when I was speaking with Juha that we have created this Square Box fictional company. So Square Box has an old data warehouse solution. It's end of life. It's difficult to develop on. And they have decided that they don't want to keep that pain alive. They want to move to the cloud. They want to start using the new technology. And they want to start doing that incrementally. So they don't want to have to wait many months or a year before starting to use the new system. They really want to remove some pain quickly and move toward the further goal one step at a time. They also have financial industry are pretty heavily regulated, so regulation imposes them to have rigorous handling of history and keep full auditability of the data. They also want to leave behind this typical release mayhem and embrace a modern pipeline with automation, continuous integration with automatic testing whenever you do a merge into master or at any time that you want to run your tests. And also, finally, have a one-click button to put things in production. And of course, you could actually do it automatically if you want to have continued deployment. They also have quite a lot of people in the company that knows SQL at various levels, but they don't have so many data engineer and developer. So they would like to be able to involve these people that also have quite a good knowledge of the business in the development of this platform. But of course, these people are not developers. They cannot be handed over to develop in Java or some other more complicated structure. And also, they would like to have a solution that can grow and is future-proof. They don't want to have to get now something huge, but they want to grow. And also, they don't want to have vendor lock-in, because of course they like us now, they trust what we are telling them, but they don't want to have to live forever with us. So they want something that they can or handle in-house, or eventually they can also have someone else to handle in the future. And lastly, it's important for them to have spending in line with benefits. So they want to avoid big upfront investments that takes years to pay off, but they actually want to start small and build incrementally, and also have the spend that goes incrementally together with the benefits. Does this resonate with you? Is something that it gets more common in data department, that you cannot really look at, okay, in 3 years we will have this, and we need these hundreds of thousands of euros. So how a typical data architecture? And now you will start to see that when we have slides with this grayish background, it will be a little bit more technical. So, but don't get scared. I will try to keep it at a level that everybody will get something useful out of it. And then, of course, if there are more technical people that want to discuss this with me, I welcome them to get in contact or make a question, and we can go as deep as you want. So the typical architecture that we use is built in a few layers, few stages. On the left, in pink, we have your data, and it is landed somewhere that your data platform can get it. And then we have a staging layer where we receive, that is the one in yellow, where we receive and adapt the source data. And adapt, I mean, we adapt the names, the time zone. We don't change the data in any practical way. We just adapt the field names, and eventually we get the time zone correct. We also calculate some technical fields. We add metadata, like when we are loading it, the data source, some effectivity dates. And of course, we also load some reference data, like ISO codes, calendar, and other manually maintained data like categorization, list of values, or mappings, that of course you have to maintain to join the different data that coming from different sources. And then from this staging, we load the data in the data vault, or what is going to be the base of your enterprise data warehouse. And we load the data in a safe, extendable, easy to use way that preserves history and is fully auditable. Both to keep it quick and auditable, we only do inserts. We never change anything. But having this effectivity and low timestamp, we can, just by inserting something with the right metadata, make it the more recent, or make them more recent regarding to some moment in time. And then we see that if we look at now, I said I have exemplified this data vault, and we have mainly 3 categories of entities. And this is one of the power of data vault, that it uses 3 concepts that are pretty, once you get to work, they're pretty used to understand, and you use them in a consistent way. You use patterns, so you don't have to invent the wheel every time. You know how to use them, and you effectively keep doing that in a repeatable and automated way. And then we have probably what is the most important part for business, the business vault. Because what we are doing here is that we are dividing a complex problem into complex, but each one of them simpler. One is to load the data effectively and in a consistent and auditable way, and that is where we get into the data vault. And then we have to take the data and actually transform that into information, because what your business people, what a company needs, is information, it's not raw data. Because there we have everything, the good, the bad, and the ugly. But then you want to take the data, make it become information, whether it is just taking the good and making it for reports, or using the bad and the ugly to understand what went wrong in your process and why you have the bad and the ugly in your data vault. So in the business vault, we take these raw data, and then we apply master data management, the business rule, and all the desired calculation to what is the safely stored data in the data vault, and we build your business entity. Those things that we were talking before with Juha. So we go from whatever we get as a portfolio changes to what is the desired representation of a portfolio and their position. And then, of course, the last step is to provide data marts, because you can cut your data model in different way for different users. And the goal of providing data mart is twofold. On one side, it has to be something that is easy to understand for the users of the data mart, and on the other side, it has to be quick and optimized for the BI tool that you are using. So on top of the same business vault where you have the refined entities, you can build different data mart for different people and also for different BI tool. Because of course, having a Power BI interface or having a machine learn application can require a different approach. And because we have seen it before with Juha, this is a very simplified, small model that we are going to use for this demo. As you can see, we have what we call security. Here I call it security because it's more generic. We call it stock. We have the position, that is something that puts together two entities, the security and the portfolio. That's why it's modeled as a data vault link. And of course, we have the data from the calendar that is some reference data. And also, we have the quote, the stock quotes, like we saw in the previous presentation. So I don't want to go too much in detail, but of course, the example that we did is that now, if we think that in this case, we get the daily changes in position as our input, then we can calculate the portfolio transition. If you would be in the other way, in the other case where you get the portfolio transition and then you will calculate the portfolio position, well, that's fine. That's how your business works. So the model can be the same, but how we calculate the things will be different. So let's get started with the demo, and let's see what we will see in the demo. So it's going to be pretty simple. I don't want to try to keep it too complicated. So I will show you a very basic bare bone report, just to show you that there is something actually running, and exemplified with the typical stock chart. And we can see that some data is not up to date. So we will look at the different layers in our data warehouse to see if the data is actually missing only in the reports or is actually missing in the data platform. And then we will see that it's actually missing in the data platform. So we will run, in our case, we have made a REST API to call a microservice that will download the data from a cloud service provider and load it into our Snowflake. But that is just because it exemplifies something that happens in many companies. You have some process that generates or downloads data and load it. But of course, if we think about being on Snowflake platform, it would be, in this specific case, probably easier to just get a service from the marketplace providing us stock quotes and just use it. But in this case, we use this external service, so we can also exemplify how it would work if you would do a kind of continuous ingestion of data from some microservice. And then, of course, we will do the path backwards to see that we actually have loaded the data. And while there will be something running, I will try to also show you some of these points. So a little bit knowing how DBT works, what we are running, some useful feature for the business users, and of course, we will go through looking at the different layer using the Snowflake interface so that you can also see a little bit of that. And well, the last thing, I will not go too much into the Power BI side, just because for us it's just a way to show you that we actually have data and that actually something happens. So let's go into that. So let's start from the end. So we have these simple reports. So you can see it's real. We have to wait for the data to load. So this is because the application is not, being a demo is not used. So we have to get it loaded on the server. And I can show you that, well, we have data that is up to the 15th of January. So we don't have all the dates. Let's see if we... Okay, so we are getting, and also Iron Mountain is up to 15th. Let's see for Apple. Okay, also Apple, and also you can see that this is actually the data as it is. We have not put a lot of business logic, being just a demo. So we actually can see that at some point Apple split its stock, and of course the new value was 1/5 of the old one. So let's go and look into our Snowflake platform, and let's see if we actually have the data. So I have one simple query here, and I will just look at, okay, so I see that for these symbols, actually I have data that goes from this date to this date. So it's true, it's correct that because in the fact table I don't see anything more recent. I cannot see, I cannot show anything more recent in our report. Let's look, okay, even in the data vault layer, that's the dates that I have, and that's the same, hopefully, in the source data. Yes, even in the landing table where the service loads the data, that's the most recent that we have. So now what I can do is that I can just go and pick the URL and run it. So I just have this application that it's stored on Azure, so it's a microservice. And you can see I have run it. I have downloaded some data for Microsoft. So let's see if now I have more recent data for Microsoft. Okay, yes, looks now that now we have it up to 19 for Microsoft. So let's do the same for Apple, and let's see if we get more recent data for Apple too. Okay, let's check it again. Yes, good. So we have downloaded data also from Apple. So of course I could go on, or I could even automate these to run every day, but then we will not have fun in the demo. And well, I could go and try to show it, but well, what we actually have done, we have downloaded this in the landing table. So I need now to use DBT to run my ETL, in this case it's ELT, to take the data to our data vault, because if I run it now, I see that the data vault yet has no data, and the same, of course, the data mart don't have the data. So let's go, and this is my home of the project in DBT. What I can do, I can go to my jobs tab, and you see I have created one that is run when we make a pull request, one that is deployed to CI, the master, and then I have made one that is used to load the new data. So I will start to run it. So you see that now we are requesting a run. This is going to be scheduled. It will take a few seconds, maybe 10, 20, 30 seconds, depending on the load on the dbt servers to get started. But I will take this time to take you to a small tour of dbt, and then we can go through in more details. So I can start from these data sources. So, and one good feature for the business user is that you can define on the data sources that you want some kind of monitor, so that your business people straight here in the browser can see when the last run was done, the last ELT that was loading this data was run, and how fresh is the data that you have in your actually data platform. So this is very important, so your people knows if you are providing, and you are inside your defined SLA for providing fresh data. And then another extremely important feature is documentation. So building a data platform and not knowing what you have is something that is pretty common. And I have actually doing some projects where the most difficult thing is to figure out what they have and what needs to be done, more than actually doing it. And so when you get some good lineage, and you see this is automatically generated, and you can see that we have the daily quotes, that is the landing table, and from these daily quotes that we are loading, we see how these are moved on. And of course, we also have some other portfolio that we load, the currency that we have, and then some base information about securities. Well, this is not the automatic layout, this not make the best job. And of course, we also have position import, and all of these come together so that we can calculate the daily quotes. This is a unit test. This is the final portfolio value. So it's become easy to navigate. And of course, you can move and reorganize and then print it out because you can easily export once you have organized the picture in a better way. But what I think is also very important is that we have all the dependency. Now, what we are doing with the job that I started running is that we are not running all the ETL. We don't need to run all the models because we have loaded data here. So what we can do without having to keep track of anything is just ask dbt, hey, run all the model that depends on these. And so we will just run the minimum amount of ELT that we need to run to actually update everything that depends on the new quotes. And another important, so let me see how the run is going actually. So let's go back and let's go to our jobs and load the new data. So, okay, it looks like it's been running. So let's look at what we have been doing in this job. So of course, we have got the data from our Git repository. We have created a connection to our database. We have downloaded the libraries that we need. And we have run, and you see we have run our application, or we have run our ELT, but just saying take only what depends on the source code. So what we actually did, that out of 35 models that we have, we just run 10 of them. So you see, running 1/3 of the model is already something that makes you your ELT much quicker, and you can run it even more often if you want to have near real data. And then we run the test, and again, even with the test, we just run the test that depends, that touch something that depends on these stock quotes that we have updated. So instead of 92 tests, we actually run only 22. And this, again, makes it simpler. And then we have taken a snapshot of the new data, and we have checked the freshness. So let's go and see what we have here. So we know that in the source system, we have recent data, So let's see what we have. Okay, it looks like for Apple, Microsoft, and Tesla, we have, no, Apple and Microsoft, sorry, not Tesla. I'm not reading well enough. We have loaded the data, so we have it, our ETL has taken the data to the vault. And then let's see if we actually have it. Yes, look like that we also have it in the data mart. So let's go and check if now for Apple, I actually have. Okay, let's see. Looks like that we got the data. Let's see also for Microsoft. Okay, loading the data, and well, it looks like that it worked as expected. And you see, in the end, it just took 3 minutes. And this is, in the end, is something that is not going to grow even if you have a lot of data, because now 3 minutes is mostly spent, as you see, in connecting and doing a lot of small steps. And we are using the tiniest possible data warehouse in Snowflake, while you could, of course, get a much bigger one. So going back to how dbt works and how we have built this system. So I was showing you the documentation, so I can go here, and I have shown you the lineage, but I think it's also useful to see that the documentation, you can actually provide good documentation that is useful for your people so they can understand. In this case, I have created a macro, and I have used some markdown to represent a good documentation about it. And because in this case, we have also different version of the macro for different databases, I can also have a reference so that when I look at one, I can click and go to the other one. But, and of course, I can do it, and you can see that you can also document each field in detail. That is also important. You get what code is using, for example, this macro. You see the macro definition. But if we go in the models where we actually write the code, and you see this, of course, being a macro, there is a little bit more Python, but it's still most of it, it's a SQL. So if we go and look at our data mart, we see how we can get the documentation. So again, we can have description that is all big or small, but we have automatically generated documentation on all the columns. And for example, we also have here documentation on what tests we are running, so that we know that in this case, on the country hash key, we ensure that it's unique and not null. And I remember you that I told you that we have 90-something tests. And you can see here what are. And you have a quite range of tests that are already default in the dbt package. Then you have a standard library that is called dbt utils that allow you to have even much more tests. But of course, you can also define your own. And it's important also that you will define your own test on the data, not only on the schema, on the structure. And then we can continue and look at all the definition. You can start to see how the code looks like. And so this is the logical code, but you can also see the compiled pure SQL. And you see that there is not much. What I was saying when I say 99 is because we want to use these logical references. That is what enabled dbt to build this relationship. Because by defining these in code, we enable dbt to build a DAG, a graph in the end, with all the dependency. And we can even go and see in a little bit in more detail that, of course, in this case, I have generated these as view, so there is not much data. There is no data physically in the database, but when you have table, you also get a little bit more of data. And again, you get the full definition of the fields, where it's used, what it depends on, and again, the source and how it's compiled. But now you probably want to go and see how is the development, because here you can very simply define the development. For the demo, I just have the development environment where every developer gets his own development environment. This is important because developers don't have to fight for a single shared development environment where if I change a table, I break someone else's code. Everybody has his own development environment. They are independent. They are managed and generated automatically by dbt. And so every developer can work with their own clean environment. But then everything's come together in CI or test or whatever you want to call them. And of course, you can define then production or all the environment that you want. And automatically, the data is moved to the branches in Git and GitHub. And then we have seen the jobs. You can define the job. And defining this job is really something that is as simple as listing a sequence of dbt commands. So this is how you define. You just set an order of dbt command that you want to run. And then let's finally go and look at some of the code. Now I'm downloading the code from GitHub, and then I want to just briefly show you some of the code and then go back. But if you have questions, please type them in the chat so that I will answer them, or if we have time at the end or after that. So the typical, so this is dbt cloud. So this is an online environment where we can develop. And if we look at the models, this is how they are. So we typically have two types of files. SQL file that, like the extension say, contains SQL. And you see that these are mostly very simple SQL with that little bit of ginger of Python scripting to know the sequence of the model, and sometimes also to build something powerful, because if you have 10 attributes that each you have to iterate over, you can use scripting to iterate over them instead of copy-paste the same code 10 times. That is not good software engineering practice. And on top of that, a lot of things in dbt you can also do in metadata. So in this case, you see that we have described the model with description. We have which column we have and which test. So you don't really need to write this kind of test. You have to just declare that you want to run. And you see that we have different basic type of tests. And of course, you have many more that you can use from the library. And this I can just show you. And of course, you can do the very normal SQL, all the calculation, all the business logic that you want. And in the end, everything is brought together by this configuration file, where you can even, of course, define the structure and what data you import, and you can import the reference data and decide the types. You can, of course, define also where and how the models are materialized, so whether they are view, they are table, or of course, in some cases, you will want to have incremental load. Definitely, when we store in the data vault, we do incremental load of new data coming into the system. I hope that I gave you a quick overview of the platform. And if you have more questions or more interest, then please ask me in the chat. So, wrapping up, let's go through this checklist and see if I have shown that we accomplished what were the goal of our square box. Of course, we have full automation, testing, comprehensive testing. I have not shown you, but you have also an easy way to write tests on the data, so to ensure that the result of your calculation are actually what you expect. We have auditability. This is a function of the fact that we always insert, we create the metadata that we store together with the data as it progresses through. We have seen the lineage. We have seen that we mostly use SQL, and you can use a little bit extra of Python and scripting to make your code easier to read, to avoid repetition. So, like you do in good software engineering, avoiding to copy-paste the same piece of code here and there. And we have been talking, we have been seeing, using the best practice, reusing code, and also on the process part. So you have seen that I have not shown. I can show you. So you cannot edit on master. You have to create a new branch. This is something that is a guided process. So even if you're not familiar with Git, you will be guided. It's easy. You just select the name, and then you do the commits over when you're working, and then you open a pull request. Your colleagues can comment. You can go to the usual process, and at the end, when you merge, you get the CI kicked so that everything is tested before you actually do the merge. And then Agile, I have shown you that we have this layer, so you don't have to do like you do typically in databases with the Kimball, that you have to solve both the problem of how to get the data coming in and also how you want to structure your data marts. So here the goal is that you divide the two moments so that you focus on two complicated jobs one at a time. So I hope that I have shown something that looks interesting to you, and I hope to hear back soon from you. I would call it now Sami, so that we will get some updates from Snowflake.
Thanks,
so,
Roberto.
Welcome. So,
how's the mic?
Good. Screen visible.
Yep. All right. So welcome from my side as well. And Snowflake up next. So Sami Rouhe is my name. I'm a sales engineer at Snowflake, started last month, based here in Helsinki, Finland. And I will be talking about some new exciting features of Snowflake, namely in the categories of data cloud content and governance and security. And I just checked the poll, and almost half of you are familiar with Snowflake, actually, but I'm going to talk a little bit about Snowflake and our positioning as a data cloud first, and then go into some data cloud content, going to show you a little bit our data marketplace, and tell about some upcoming features in that domain, and then go into governance and security, talk about dynamic data masking, object tagging, and row access policies, and tying this up to the theme of DataOps. So first, a little bit background for Snowflake and our journey to a cloud data platform. So Snowflake was really the first platform to answer all of these questions that you see on the slide. So we want to accommodate all of your data. So no matter if you have semi-structured, unstructured, flat data, you can use it in Snowflake. All users without any concurrency issues, fast answers, and easy to use SQL database. So the journey here started with these on-prem data warehouses that we used to have for decades already, and they were good at a time, but at some point when the data got more complex and the demand for analytics rose, they didn't answer the questions anymore so efficiently. So then we got these first generation enterprise data warehouses in cloud, and those did a little bit better job, but they were still essentially just the old technology ported to the cloud. So some same problems still existed. And then we had Hadoops and all the other data lakes which were popular at some point, and they were really good at storing the data. And no matter what kind of data, you could actually put it in there. But then the complexity and the
it was just hard to use, and it didn't really cut it to be the #1 data platform that we would use. So Snowflake is the one that was going to answer that problem. So this is our rainbow slide and our architecture that everything in Snowflake is based upon. So as you see in the bottom, we're cloud agnostic. We run on all major public clouds. The user experience is same no matter which cloud you're using. And so we got centralized storage and a compute layer that are separate from each other. So the storage means that you can store any amount of data with infinite scalability using the underlying efficient blob storage of the cloud. So all formats of data, you just dump it in there and the storage is never going to run out. And then you got these little gears on top of it, which represent compute clusters or virtual warehouses. So you can have any number of those in Snowflake for all kinds of workloads. So no matter how many users you have or no matter what kind of workloads you have with different demands, you have a dedicated compute cluster for those. And they operate on the same set of data without you experiencing any kind of concurrency issues from one another. Then we got the cloud services layer, which is essentially the brain of Snowflake. So this takes care of a lot of maintenance jobs, for example, that you would use to have in the old world. So indexing of tables, pruning, vacuuming, figuring out the right file storage format. All of this is handled for you, and like the query optimization, metadata of the data in Snowflake, security and governance is handled by the cloud services layer. And the architecture that I just showed you enabled Snowflake to be really a revolutionary data lake and data warehouse at first. But since the technology works so well, we have expanded our offering to include these other workloads as well. So for example, for data engineering, Snowflake is a really good fit because you can leverage the scalable compute of Snowflake and handle your semi-structured files and, for example, prepare data sets for data science workloads. And then you can power data applications by using Snowflake as a really scalable and cost-efficient backend for your apps. And the data exchange workload on the right, that's the really exciting one. So we offer in Snowflake data sharing features cross-cloud as well and cross-regions. And this is the big part what enables Snowflake to be the data cloud that we are talking about. And the data marketplace is going to touch on this workload as well. And we're going to be looking at that in a little while. So Snowflake is essentially in the middle, handling all these workloads. And then you just have on the left your data sources, on the right your data consumers, and everything else is done in Snowflake on the same data. And these are the regions that Snowflake is now available on. More are coming, of course, but as you can see, we're available on all the 3 clouds across the world, and we have the cross-cloud data sharing capabilities, database replication capabilities, synchronization. So this is what it means to be a data cloud, that once you're in the Snowflake ecosystem, you have access to all of this data cloud across the whole globe. And that the word data cloud is going to get some more meaning in a while when I show you a little bit about our data marketplace. So let's look at the data cloud content now. And these features support DataOps as well, but all in all, these are really interesting and new stuff that we have. So we're now in the data sharing workload that I just showed you. And I'm going to now jump to my Snowflake account. So we're going to be looking at that data marketplace that I was telling you about. So this is the basic Snowflake user interface, what it would look like to you as well if you would be logging into your own Snowflake instance. So we got this data marketplace tab up here. And yes, I want to explore the Snowflake data marketplace, and it opens up a new sheet for me. So it looks like this. So for example, we have different kind of categories here. So these are categories that I can browse to look for new data sets for my business that might be interesting to me. And we have different data providers in the marketplace who are offering their data sets to be used by the data consumers in the marketplace. So let's, for example, go look at health category. And of course, there's some COVID data here. So here, for example, this is a data listing. So I can see that it's offered by star schema. It contains COVID data, apparently. And if we're now looking at this, I can see a description of the data. We even have some example use cases that we might be able to use it for. We got list of tables included, fields included. And we even got some sample SQL here. So it's really simple to just start to explore that, get the data for yourself and start to explore it. So, okay, fine. I'm interested and I want this data set. So I'm going to click on get data. And I'm just going to create a database out of it. And I just have to define roles which will be able to access the data and accept consumer terms. So let's pause here a little bit. So in Roberto's really interesting demo, you saw a way to get some stock data out of an API. So this is what it would be previously if you would want to get a new data set that you would want to use in your business. One way would be to discover a new API and make connectors for it and build the data pipeline, do the transformations, maintain it, run it, and so forth. So that's really interesting and exciting to build for yourself, but it takes time and resources. And there are some problems in those kind of methods that, for example, if the data volumes are really huge, it might be really impractical to get like a terabyte size table for your use. And then other ways that you would maybe previously share the data would be to use FTP servers or just extract CSV files out of your database and send it to your partner or consumer or whoever. And the problem with that is that once you extract the data and you send it out, it's already outdated and stale, so it's never up to date. And once this gets going, for example, internally, you might have a lot of different Excel and CSV files going all around and nobody knows what's the exact current data. So the data is not reliable necessarily. And there's security implications as well, because once you send the data to somebody, you're not going to get it back if you would wish to do so. So with that in mind, now in Snowflake, this is COVID data, but this could be stock data as well. So what I need to do to get the data for myself. So I go to browse the marketplace, I find the data, I click create database and done. Now I got the data. So it's as simple as that. So now I'm back in my worksheet interface and I can see that I got the data set now here. The new database created out of the data share, and all of these tables containing the COVID data that I can now use joins to use with my own data, or I could even connect like BI tools to create dashboards out of this data and so forth. So we can go look into the data, basic stuff, use cases by regions, for example. Then we have some mobility data from Finland. I'm not even 100% sure how to use this particular table, but you see that the data is almost up to date here. And this particular table is not updated daily, I assume, but if we look here, we can see that this data set is actually maintained all the time. So you have up-to-date data of the COVID if you would wish to use this for your use cases. So that was the marketplace shortly. So going back to the slides, the marketplace is one of the three features that we offer in the data sharing domain. So as you could see, we can go in there, browse by category, see data listings and get the data for our use. And then other use case would be that we have a data exchange, which is essentially the same thing as this data marketplace, but you would use that internally with your own business ecosystem. So for example, I could use it with my suppliers, partners, and I could invite them to my data exchange and we could collaborate on the same sets of data. And then we also have direct sharing. So if I would just want to share data directly to one of my partners, for example, I could do that too without setting up a data exchange or putting it up to data marketplace for everybody to see. And if we think about this with the DataOps perspective, so what DataOps wants to do is to create a quality data product. And what the Snowflake marketplace, for example, does, it makes it so much faster to get the data from the source to the end user. So it makes the build phase of the DataOps pipeline really fast. And then if you think about it, about the data quality as well, since the data is always live and up to date and there's no random copies of the data going around, it's always the same live data. The data quality is going to be as good as it gets. So in this example as well, the data that I got from the star schema provider, it still resides in their database, and I'm just querying with the share the exact same data that they have. So if they would make an update to the data, like add a new row about some new cases of today, I would immediately see that in my own table. And this is what powers the data cloud as well, which I was talking about. So since this data sharing already works globally across regions and cloud providers, if you think about it, when you join the Snowflake, you basically get access to this big network of data, and the network of the data is essentially what the data cloud is and what has the value. And then in the data marketplace, there are some new things called data services. So if we look at the slide, so it can be used to deliver enrichment or analytics to your own data. So there are two models in doing this. So for example, if I'm a data consumer, I could share my data with the data service provider and then get the enriched data back to me. Or the data service provider could provide a UDF, user-defined function, for me, which I could call in my SQL and then enrich my own data in that way. So the example might be thinking about the financial company. You could, for example, have a table data containing your customers, and you would want to get a risk rating for them. So then you would maybe call in this financial data service provider with your own data set and then get the risk rating back to your data. So enrich your data in that way. Or simpler example would be that you have data in table that has coordinates in it and you just want the live update about weather back to that same table. So you could use the data services in that way as well. Cool, and these are things that are already available to Snowflake customers, at least in public preview, and some of the themes in 2021 that are going to be added to this data cloud domain. So a big theme is going to be that we're going to enhance this global data sharing even more. So at the moment it works, but we want to make it as seamless as possible, that no matter which region, which cloud provider your dataset provider is going to be, you're not going to notice any difference. You're going to get the data available globally from the data cloud. Then we got Snowlink, which is a feature that, let's say if your company uses multiple Snowflake accounts, let's say Snowflake account A and B, and I have to use both, but I don't want to go log in, log out of both of those constantly. So I can just use the Snowlink to execute remote commands in the other account by just logging into the account A. And then everybody's heard the phrase, data is the new oil. So we're going to make it easy to monetize the data, which Roberto was talking about actually. So if you are a data provider and you put the data set up to the data marketplace, you can just put a price tag on it. Let's say $200 subscription fee per month or something. So it makes it really streamlined to monetize the data if you have something that others could benefit of too. And we're planning to even enable monetizing scripts and, for example, external functions that you might use in Snowflake. And then we are going to provide usage metrics for the data providers if you want to get a feeling of how your data consumers are using the data sets that you provide actually. Cool, that was the data cloud content, and then some stuff about governance and security. And like you see on the slide, this is a really important theme in Snowflake overall, and it touches on all of the workloads, obviously. But I'm going to talk about some new features that might be really helpful in the use cases seen today. So first, we got dynamic data masking, which means that you can, at query time, dynamically mask, partially mask, or fully mask some sensitive values of your data. And this is policy-based and centralized, so a policy admin creates a policy that you can then assign to one or more columns in multiple tables. And this has a lot of useful cases. So for example, this prevents secure view explosion, obviously. And then since this is executed at query time, you don't actually change the underlying data. So you ensure that the data quality stays good since you're not changing the underlying data. And it's really easy to apply. You can use this for external tables as well with data sharing and so forth. So just mask the sensitive values. And the partial masking is nice too, because there might be cases where you don't need to mask the whole value, and you can partially mask it so that you can maybe use the remaining clear text values in your analytics. So the policy might look like something like this. So you have a policy admin who creates a policy, and it has a condition that then you're going to apply the masking under those conditions. So for example, if your role is this, then mask the whole value. If your role is this, show the value, else mask partially, or something like this. And supports all the data types, supports data sharing, streams, and clones, like I mentioned. Then we got object tagging, pretty cool feature. So obviously you can use this for the security use cases. So you have an admin who can create a tag, and then the data owners can assign that tag to the data that they want. So you can classify sensitive data or something that shouldn't be unauthorized accessed in your database, and this makes it really easy to audit what you have in your database and keep track of the sensitive values. And you can use this with the data masking, obviously, as well. And you can also use this for tracking consumption. So you could assign tags to Snowpipe, virtual warehouses, materialized views, clustered tables, and group them up together and see the consumption in those groups. And then finally, we have row access policies. So this is filtering rows at query time based on the user role and lookup table. So for example, in a case of a financial company operating in multiple countries, let's say I'm a manager in Finland, and there's a big underlying table containing data about all the regions, and I just need to see I'm authorized only to see the data from Finland. So you can centrally create these access policies so that when I query the data, it's going to apply the filter at query time, and I'm going to be seeing only the rows that I'm supposed to see. And it's centrally managed as well. And you can apply a single policy to multiple tables, and again, prevents the secure view explosion, supports external tables and data sharing. These were the new features that I wanted to share with you. And just at the end, our customer base is expanding rapidly. We have thousands of customers already globally using Snowflake in production. And in Finland too, interesting customers joining all the time. So keep track of the list, it's expanding rapidly. And then in the ecosystem as well, there's some interesting new partnerships. So for example, with Salesforce, we have a tight collaboration going on. And we have been, for example, with DataRobot, we have close cooperation with them as well in the machine learning AI domain. So keep an eye out for that as well. Right, thanks. That was all from me.
So thank you, Sami. So it seems that it don't leave yet. So it seems that the data sharing and the data market it's speeding up and there's more engagement. Do you see that in Nordics or Finland?
Yeah, there are definitely customers who are really interested in using the data sharing feature and the data exchange as well. And there are actually cases where customers of a company come to us to say that please get them to use the feature because it's just streamlines the processes a lot.
Yeah, great. I think we are still on time. We have 20 minutes for the Ask the Expert sessions. I would like to invite Roberto and Juha to join us. You guys been really active on posting the questions, and I see that also some of the presenters have provided some answers, but there is still loads of questions that I think we need to answer. So I guess this first question is towards you, Roberto. So do you use an orchestration tool like Airflow or Prefect with DPT? And we only have 2 mics, so Sami, if you can hand over the mic.
Yep.
So we can pass it over so attendees will hear. So.
Okay, so hopefully you hear me well. And the answer is it depends. You can do, but for example, what we tend to do is to use dbt Cloud so that we get a software as a service experience, and we don't need to have any external tool. But for example, if you want, you can use the open source, fully open source dbt, and then use Airflow or Prefect to actually trigger the runs.
Yeah.
Then anyway, the run itself is managed by dbt because it knows the sequence on how to call the different models.
Good. Okay, I guess the second question is for Juha. So in what kind of companies Ellie is used in Finland?
Right, so I would say all kinds of companies, but interestingly, it's been quite big in the healthcare sector. Because there's kind of all kinds of different data about healthcare. You have the visits in hospitals, you have X-rays, you have patient records, and everything has to connect in some way. So understanding that structure in the healthcare business has been very important. But like process industries are big, and public sector is growing, I would say, and all sorts of industrial businesses also now coming up because you can kind of understand the connections between like IoT data and your kind of traditional business data better when you do it first on the conceptual level.
Yeah, I guess you can continue as the third question is about Ellie data modeling as well. So how would you create the physical data vault model based on the Ellie concept data model?
Right, excellent question. I'll try to be short here, but the idea is that if you remember from the Ellie presentation, the model that we created with Roberto, that there were these color codes for those entities. We had the entity types identified. This is a transaction, that is master data, and so on. These can be actually utilized to kind of derive a set of rules according to which you can then build the data vault model. So for master data entities, like we had the portfolio and the stock and so on, these would become the hub table. This is the normal way of doing that. The contract type entities, the position usually also is a hub table. The transactions usually become links, and of course all the relationships then require link tables and so on. But there are some like stylish changes there that you can kind of build a hub heavy data vault or a link heavy data vault, and based on that we can then sort of adjust those rules. But this is actually being done in quite a few Ellie customers. So it's mainly a matter of finding out the style of data vault that you're doing and then setting up these rules basically from that point of view.
Yeah. I know that data lineage has been sort of a question that has been discussed about a lot, and I guess this might be towards you then, Roberto. So can lineage graphs show SQL or use source columns and transformation for each result table?
Okay, so you cannot show this directly into the graph, but then sorry if I was not clear enough. One of the great features is that when we were looking at the lineage graph, you can click on any entity and go to the detail page. So you were there, you see all the column, all the text, all the information about that. So you can navigate back and forth between the lineage and the documentation. So sorry if I was not clear enough in showing that. Point taken. Next
Okay,
time I will
good.
try to make it clear. And one other thing that I can add on the previous point, and if you want to go even deeper, so when you have decided how the hub, link, and you have created this data model, of course, if you use a lot of automation, how the physical model is derived is actually built into the markers that you use. So you don't care so much. And if you use a tool like Snowflake, where you don't really have to create indexes and so on, you don't even need to care unless you really have very, very strange situation. And that, I think, it's another great point why patterns, best practice, and automation can work well together in this kind of environment.
Yeah. Thank you, Roberto. So it says that there was also IDW mentioned in the slides. What is that about? And maybe I can start. Maybe you can elaborate. So IDW is short from Intelligence Data Warehousing, and it's Kaito's framework, service framework around data management, data modeling, and basically using DPT to speed up the development and trying to get the value more quickly than traditionally. But is there anything that you would like to add about IDW?
Yeah, I think it's a way to say that we have an organized way to approach this kind of project. We have blueprints, so we have a way to progress in an orderly way to this project instead of having to start from scratch every time.
Yeah.
So it's an organized way of building something using the tool that we have shown.
Yeah. I think the next question is for Sami. So is it common to use Snowflake even though your data and analytics is driven by Azure or in Azure?
Yeah, sure. So many companies, they are obviously using one of the cloud platforms and the services that they provide. So Snowflake fits very well besides those other services that they might use as well. So it doesn't mean if you use Snowflake that you then use only Snowflake and maybe the native connectors that you have in the sheet. You can use Azure services for sure.
Good. Thanks, Sami. Then the seventh question is about real-time data. So not sure who would like to answer, but the question goes like, is the referred architecture applicable to real-time data also?
Maybe I can start, and so I can probably start, and then I think that I will pass because it's also logical progression. So, of course, real time can be defined in many ways. If we go from the traditional 1 day load, and if we go to 15-minute load, is that real time enough for you? In that case, I can already tell you, yeah, that's doable. And I've been also working in a company where we're doing 1 minute load. So that is probably the boundary where you have to start looking at how you do it, why you do it, and then I pass the microphone to Snowflake because they've been working also on making this easier and allowing people to do more real-time load.
Yeah, I would have said exactly the same as Roberto. So first, define real time. So it, depending on a case, it might mean sub-second or even once a day, depending on who you ask. So the 1 minute is probably a good threshold. So Snowflake is good at doing near real time, but we are not focusing on doing the sub-second, millisecond type of latency real-time stuff. So for that, we usually recommend using some other tool. But for the near real-time use cases, definitely works.
Yeah, maybe a Lambda architecture where you have most of the data almost up to date, up to the last moment in Snowflake, and then something else.
Yeah, so commonly you might have different types of data pipes, so batch loads, and then the near real-time loads, and then the real-time load might go through some other BI tool, for example, and then back to Snowflake after that. So
I can do so. And one reason why we have selected this kind of demo is because I have shown it took 2 minutes to actually run the full ETL. So that is something that you can trigger about that. And if you probably, instead of using the tiniest possible Snowflake instance, even if you have much more data, you use a bigger one, you definitely can scale it up, and also more nodes in the cluster. So you can probably go from 2 minutes down to probably a quarter, a tenth. I don't know exactly, depends on your data, but you can definitely use that logic that you run it every X time, or you trigger with a REST call.
Good. Okay, thank you. I think we left the biggest question to the last. So not sure whether Juha would like to start, but could you explain what exactly is Data Vault?
Okay, yes, this is relatively big question, so we could have a separate webinar about that. But in short, I would say that, and Roberto, you can fill me in with the rest of the details. But I would say that it's a very, very modern way of doing data vault structures, so designing the structure of your data warehouse. And it has a certain set of rules that you need to follow, and following these rules, following this structure gives you certain kind of abilities that you wouldn't have otherwise, like full history of all the changes and so on and so forth. So it's a style of designing data warehouses, but it is a very, very well-defined way of doing that. And we have, there's a certification and everything that you can get of it. But Roberto, would you like to fill in some details?
Yeah, I would say that you can consider Data Vault really, like you said, an architectural style of building, plus, and it's not just the technical part, plus a set of best practice also of how managing the project. So I think it is just one way of building. We also said we don't really need to build in Data Vault style or using Data Vault entities, but we find it a good approach because it's really bends well to automation. It's also pretty well known in the market. In the end, it's really proven. It's been studied in the 90s, and it's in production in huge companies since the 2000. So it's at least 20 years that has been adopted from version 1, now version 2, and at a huge scale. So if you consider Lockheed Martin, it's probably big enough to grant you that it's complex business with a lot of units, with a lot of international, also safety, because it's, of course, defense material. Also, Department of Defense is using Data Vault. So it's a proven technology that, as you said, is still very modern. And also, what I personally love, the two things that I love most is, one is the focus on building the business models, and the other one is this separation between storing the data in an accurate way, that is already a big problem, and then separating from how you actually add on top of that the business logic. Because also doing that, it allows you that you already have the data, you can start building some other business logic. You then don't have to change the load. That is something that many times when you do Kimball style, you cannot add logic because the logic is together with the load. And if you change the logic, the business logic, you also change the load and it breaks everything that is already deployed. So this way of working allows a lot of parallelization also on what you build. Because many times you already have the data, you just want to use it another way. So you don't need to change the load. And on the other side, if you want to start loading something more, the business that is already there is working. It keeps working the same way. It's not impacted by the fact that you add more system, more data, and you store it for future use. But you start storing with a full history right now.
Good. So I guess we are running to the end of the webinar, and I would like to thank the attendees for attending. I hope you got new ideas. Obviously, there was good questions. I think good answers as well. You feel that there's still questions that you would like to raise, so I'm pretty sure that the gentlemen here are more than willing to answer those, so you can contact these guys. So I would also like to thank Sami from Snowflake, Juha from Ellie Technologies, and obviously Roberto from Kaito. And what can you say? Keep safe.
Thank you.
Thank you.
Thanks for attending.